In this lecture, I will consider the document similarity measures. You can divide the document similarity measures into three different categories. First is knowledge-based word semantic similarity. Second is corpus-based measure of semantic similarity, and third is explicit semantic analysis. In knowledge-based word semantic similarity, we will cover the shortest path similarity, Leacock, Kode similarity, Lesk similarity, Wu, Palmer, and similarity matrix, and Resnick information content-based measure introduced by Lin, Jiang, and Correct-based measure of similarity, and Christ and Onge's measure of similarity. Corpus-based similarity measure, I will basically cover point-wise visual information, normalized Google distance, similarity distance. So first we will start with the use of semantic similarity. The starting is the text similarity. What is the use of different similarity measures, especially text-to-text similarity? Is useful in information retrieval, text classification, word sense disambiguation. Information retrieval means query versus document. Suppose we have some query like what is document, like document clustering. You want to know about document clustering, then we can fire such query, and we can use the semantic measures to rank the documents which are most suitable for document clustering. Text classification. Here we can use the similarity measures to check whether documents are suitable for any category or not. In word sense disambiguation, whether given word which may be similar, whether it fits to certain context or not. Automatic evaluation. We can use semantic similarity for automatic evaluation of summary or like that. Machine translation, we can check by using similarity measures, we can check whether it matches with gold standard or with generated summary or not. And in text summarization, we can use the similarity measures to get our semantic score in generating summary also, and in identifying the duplicate but different words also, or similar words also. And word-based similarity, word can be similar, like if they mean same thing, like synonyms, antonyms, if they mean the opposite, if they are used in the same way, like to represent just color, not particular color. They are used in the same context, like doctor, hospital, or a scalpel. One is the type of other, like type of similarity, like poodle, dog, mammal, etc. Now the issue is how to calculate the semantic similarity. The best known technique which uses the knowledge base. This is highly used technique, but based on some human developed knowledge base. Knowledge base like Wikipedia, annotated resources like WordNet, large text corpus is used to achieve such kind of semantic similarity. At the starting, we identify the relationship among words on any given document with the help of the above discussed resources, and then apply some metric or produce to calculate the semantic relations between word pairs. For example, suppose if for a given text we just identify the relation among the words of the given text by using word net. For example, fish, an animal; mammal is a part of animal; reptile is a part of animal; amphibian is also a part of animal; again, horse is a part of mammal; cat is an example of mammal; mare and stallion is a type of horse, like that. So the first part of such a system is to use the word net or some annotated knowledge base to identify the relation among the words in the given document, and by using such it prepares the hierarchy or graph. Sometimes it uses creates just hierarchy of relations to show the relations among the words in the given document, or sometimes it prepares a graph. Now the next part is how to use this hierarchy or graph in calculating the word semantic similarity. So the first technique is the shortest path similarity. It determines the similarity between two words by using shortest path. For example, to identify the similarity between cat and animal, we will just check the shortest path between cat and animal, and 1 divided by shortest path length will be give the similarity score between cat and animal. In this equation, length is the length of shortest path between two concepts using node counting, includes the end node also. The other is Leacock and Kode similarity. It is determined as similarity is equal to minus log into length divided by 2 into d, where length is the length of the shortest path between two concepts using node counting, and d is the maximum depth of the taxonomy. For example, here maximum depth, suppose it is 10, then d will be 10. Lesk similarity. The lesk similarity of two concepts is defined as the function of overlap between the corresponding definitions as provided by a dictionary. It is based upon the algorithm proposed by Lesk and a solution of word sense decentralization. Wu and Palmer based similarity measures. Metric measures the depth of two given concepts in WordNet taxonomy and the depth of least common submer LCS, and combine these figures into a similarity score. For example, horse and cat, it identifies the LCS score first and the depth of concept 1 and depth of concept 2. Means here it will first depth of concept 1 means depth of horse and depth of cat, and then LCS score it will be 2 here. By calculation we can get the similarity score between here horse and cat. Measure introduced by Resnick. It returns the information content of the least common submer of two concepts. Means information content of LCS. Here information content is minus log PC, where PC is the probability of encountering an instance of concept C in a large corpus. Knowledge-based word semantic similarity. Next is the measure introduced by Lin. It builds on Resnick's measure of similarity and adds the normalization factor consisting of the information content of two input concepts. Here similarity is equal to 2 into information content of longest common submer divided by information content of concept 1 plus information content of concept 2. Similarly, slight modification proposed by Jing and Conrad. Similarity is equal to 1 divided by information content of concept 1, information content of concept 2, minus 2 into information content of least common submer. information content of any path, probability of encountering instance of concept C in a large corpus. Means how many times particular longest common submerge exist in a document divided by total number of documents. Hers and Estponge measure of similarity determines the similarity strength of a pair of scene sets by detecting the lexical change between the pair in the text using word net hierarchy. Now the next is the till now we considered only the knowledge based word semantic similarity, in which we use the knowledge base like word net etc., human annotated knowledge base to identify the relation between words in the given text, and based on that relation we identify the similarity among the words or between words of two documents. Now suppose we don't have such kind of annotated corpus or annotated system, then how can we identify the semantic similarity? For that we can use the corpus. Corpus-based measures differ from knowledge-based method in that they do not require any encoded understanding of either vocabulary or grammar of text language. In many of the scenarios where corpus-based measure would be advantageous, robust language-specific resources like WordNet may not be available. Thus, state-of-the-art corpus-based measures may be the only available approach to the corpus-based measures in language with scarce resources. Initial setting for corpus-based measures of semantic similarity. It uses the document vector representation of text in n-dimensional space, where n is the number of unique words in the pair of text. Each of the two texts can be treated like a vector in this n-dimensional space. The distance between two vectors is an indication of similarity of two texts. Now first we will understand what type of representation it uses. It uses document vector representation of the corpus. So to achieve the similarity in this case, we first represent, suppose we use Wikipedia article. Then we represent every Wikipedia document as a row, and every unique Wikipedia words as a column. Here we will store the words W11 and their occurrence frequency, W12, their occurrence frequency, and so on. So first we will convert the entire Wikipedia documents in this form, and after that we will apply the corpus-based measure of semantic similarity. So first is the point-wise mutual information, PMI. It is a common approach to quantify the relatedness. Here we will discuss about three ways to measure the term relatedness using point-wise mutual information. The one is based on the Wikipedia page count. Here, point-wise mutual information between two terms I and J can be calculated as Pij is the number of Wikipedia articles containing both terms. N into Pij, n is equal to total number of Wikipedia articles. Pij is equal to number of Wikipedia articles containing both terms I and j. Pi is equal to number of articles which contains term Ti, and Pj equal to number of articles which contains term Tj. Pij we can consider it as like here I and j used to represent the term Ti and Tj respectively. The second is based on the term count in Wikipedia articles. It can be calculated with a term count, point-wise mutual information based on term count of term I and j can be calculated as log base 2 into t, where t is the number of terms in the Wikipedia and Tij is equal to number of Ti and Tj, number of times Ti and Tj occurs adjacently in Wikipedia, and Ti is the number of terms Ti into Wikipedia, Tj is equal to number of terms Tj in Wikipedia. The third one is a combination of above two point-wise mutual information ways, and it is actually more powerful also. Point-wise mutual information based on combined approach for term I and j can be calculated as log base 2 n into n is equal to number of Wikipedia articles. Ptij indicates that number of Wikipedia articles containing term Ti and Tj as adjacency. It is obvious that point-wise mutual information on combined basis can be give less score but more accurate with respect to point-wise mutual information based on the page count. More strict and accurate for measuring the relatedness, where Pi is equal to number of Wikipedia articles which contains term Ti, Pj is equal to number of Wikipedia articles which contains term Tj. To calculate such kind of situations where two terms occurs in adjacency, means suppose we consider these are the two terms, then we can consider that those two terms occurs in adjacency. To recognize such kind of terms, we can make some change in the representation of Wikipedia article. Here in case of word, we can use the bigram based model, means instead of storing just word, we can store all bigrams. For example, suppose Wikipedia articles contains word like, then we will store, like here we will store document D1 contains this type of word sequences, then we will use W1, W2, and then in second column we will store W2, W3, and third column W3, W4. By using this we can count such kind of adjacent words occurrences and apply it here. Now the another corpus based similarity measures is the Google normalized Google similarity distance. It is a new measure for measuring similarity between terms proposed by Calabresi and Venati based upon the information distance and Kolmogorov complexity. It could be applied to compute the term similarity from World Wide Web or any other large enough corpus by using page count of the terms. This is important part. Actually, Google distance is the semantic similarity measure derived from number of hits returned by the Google search engine for any given set of keywords. Keywords with the same or similar meaning in natural language sense tends to be too close in the unit of Google distance, while words with dissimilar meanings tend to be further apart. According to normalized Google distance between two terms x and y can be calculated as maximum of log fx. Here fx and fy are the number of hits for such term x and y respectively. And fxy is the number of web pages on which both x and y occurs. So maximum of log fx log fy minus log j xy. Here we can use f also. Log m is the total number of web page searched by the Google, and minimum of log x and log fy. If the two search terms x and y never occur together in the same web page but do occur separately, the normalized Google distance between them is infinite. If both terms always occur together, then normalized Google distance is 0 or equivalent to the coefficient between x squared by y, x squared and y squared. Now the corpus-based measure of semantic similarity. Another example that I already discussed is a cosine similarity. How to calculate the cosine similarity measures between two terms. Suppose term 1 contains, or document 1 contains 2 times the word 1, 3 times word 2 and 5 times word 3. Document contains 3 times word 1, 7 times word 2 and 1 times word 3. Then cos theta will be equal to, how you can calculate this? There are two techniques. First, by using this, and one simpler version is to calculate the root of precision into recall. This will be equal to suppose this will be equivalent to or equal to T1 intersection this will be equal to T1 intersection T2 divided by root under T1 into root under T2. Now after calculation we can easily identify that T1 intersection T2 will be equal to, how many terms are common? 2, 3 and 1. So this will be equal to divided by cardinality of T1 into cardinality of T2, and this will be equal to .6758. Now cosine similarity example. So suppose there are two documents. and we have to calculate the cosine similarity between two documents. Then documents D1 contains Gilbert 3 times, Hurricane 2 times. Here contains Gilbert 2 times but Hurricane 1 times. Document D1 contains rain 1 time, rain 0 times, storm 2, storm 1, like that. For selected terms, we are not considering all terms, we just use some selected highlighted terms. Then cosine similarity will be equal to like that. Now the another thing is explicit semantic analysis. It determines the extent to which each word is associated to every concept of Wikipedia by term frequency or some other methods. For a text, sum up the associated concept vectors. For composite text concept vectors, it compares the text using the standard cosine similarity or other vector similarity measure. Advantage: the vectors can be analyzed and tweaked because they are closely tied to Wikipedia concepts. An example and system setup to calculate the explicit semantic relatedness score. I referred this from here. First, building a semantic interpreter, Wikipedia articles, build a weighted inverted index. These are the words, and weighted list of concept of Wikipedia articles, weighted inverted index. Now we have two texts, text 1 and text 2, semantic interpreters, weighted vector of Wikipedia concepts, vector comparison, and relatedness estimation. Means here we totally depends upon the Wikipedia terms relations in Wikipedia to calculate the semantic similarity between two text documents. So sometimes it may not be very local for any documents and may misguide in some cases.